Hey everyone, how's it going? It just dawned on me that I left my clicker, so I'm going to just walk back here, but I'm still going to talk to you. So to fill the air while I'm back here, can we get one more round of applause for the organizers? They've done such a good job. And you don't always think about it, but the two people who have been on the stage being hosts all day, they have not gotten a break. They've just been here nonstop, making jokes, making you all happy. And so one more round of applause quickly for the two of them. Okay, cool. That's probably enough stalling, right? You want me to just start talking. So this is the hilarious misadventures of being a platform downstream from your language. What does that mean? Well, I'm not going to tell you right now, because that's what the talk's about. Hedge. So I put this in front of all of my presentations, not just because I like burning time, but because I like psychedelic cat art. I just stare at it. And at first, I did this as like a calming exercise, and it works. Like I'm really, really calm. But it's also a way for me to find out how cool the audience is. Because if you laugh, I know that this is going to go well. If y'all are like dead silent the whole time I'm staring at that cat, I'm in trouble. And as a warning, as you would normally think about with any sort of talk having to do with open source standards and technical bodies, if you're prone to seizures, you may want to leave the room. And I'm like half joking there, but this isn't the only one. So my name's Myles, and I'm a developer advocate at Google, focused on Google Cloud Platform and the Node.js ecosystem. So if you have questions about Node or questions about running Node or stuff like that, I can help you. Machine learning, I can point you towards the people who know. But this thing on the bottom is important. If you do public talks, just throw it in there anyways. These are my opinions. They're not necessarily my employer's opinions. So when I'm wrong, it's my fault, not theirs. So let's go back to the year of 1995. I was 10. It's the year Jerry Garcia died. That just dawned on me. Now I'm not as chipper. But it's also the year that Brendan Eich created a language called Mocha. How many of you have heard of the language Mocha before? Not the testing framework. Mocha was written in 10 days, which is pretty amazing. That's 2 days more than the oil lasted in the temples during the holiday of Hanukkah. 4 months later, they decided the name didn't work and they switched it to be called LiveScript. 2 months after that, it was renamed JavaScript, what we know it as today. There's a whole other talk all about the politics of why that happened. That's not for today. But over the next 2 years, the language was standardized as ECMAScript at ECMA International. ECMA stands for the European Computer Manufacturers Association. And it was standardized as ECMA because the trademark for JavaScript was not actually owned by the language. And that's some interesting research to do. So it begs the question, is it actually called ECMAScript? Is it JavaScript? If it's, does that make JavaScript ECMAScript's monster? I don't know, it's confusing. But one good way of thinking about it is that ECMAScript is the standard and JavaScript is an implementation of that standard. And so is ActionScript 3, actually, if any of you ever played around with that. So today, we actually have a lot of implementations of the JavaScript language. We have in Chrome the V8 engine. In Edge, there's Chakra and the open source project Chakra Core. In WebKit, which is the rendering engine and main engine behind Safari, you have JavaScript Core. In Firefox, you have SpiderMonkey. All of these different browsers have their own implementations of the JavaScript language. And the purpose of these standards bodies and the purpose of ECMAScript is to make sure that we don't have inconsistencies in the browser, or at least that's the blue sky ideal. I'm pretty sure every single person in this room has dealt with inconsistencies once or twice. Otherwise, we wouldn't have had jQuery. But they're all implementations of the standard which is known as ECMA 262, which is right now standardized as the ECMAScript 2017 language specification. You may have known it at one point as like ES5 or ES6, but they switched to doing it on a yearly basis. But we'll come back to that. Let's talk about Node, because that's, I do Node things. I sit on the technical steering committee of the Node.js project. I do a lot of the releases, so if you use Node v4 or v6, I probably cut that release. And I've also done a lot of work with the V8 team for the versions of V8 that we embed in Node. So Node was created by Ryan Dahl. It was first introduced at JSConf in EU in 2009. I think we have some of the organizers in the room right now. I guess you're kind of responsible for all this JavaScript. But the interesting thing is that Node.js has actually never implemented JavaScript. And that's because we inherited it. The engine was bootstrapped in. When Node.js was made, Ryan Dahl took the V8 project and embedded it into Node. V8, the engine is written in C++. It's written in such a way that you can use it as a library and embed it in your project. And there's all sorts of different embedded environments that run JavaScript, from robots to toasters to ATMs, and that's really scary. But Node didn't implement it. And because we inherit it, it means we get all of those language features from the version of V8 that we embed. This isn't really our choice. And this actually ended up being one of the major conflicts that caused the IO.js fork. The version of V8 that was embedded in Node 0.10 was really old. This was around the time that ES6 was starting to come out, and there was no clear path to when a new version of V8 was going to get into Node and when new language features would be available to developers. This was creating an even further divide between the browser and the Node environment, and we started seeing projects like, originally it was called 5 to 6, and then it became Babel. 6 to 5. You don't want to transpile to code you can't run. And so this was something that the project reconciled, and now we're actively updating V8. But that's not without its challenges. Because in turn, as we mentioned before, every time we update V8, we update the language features that are offered in Node. And ready or not, here they come. And I don't know if we have any Canadians in the audience, but this is a really dank reference. But so let's talk about a practical example here of how Node gets really weird with adopting these features. So Node v7.7, we updated V8 to 5.5. We originally had it on 5.4. We made an ABI compatible version, and I'll tell you more about what that means later. But we were able to actually update the V8 version during the life cycle of Node. And with it came async await, which I think is one of the coolest features to come into the language in a while. It's a completely different paradigm of thinking about asynchronicity. Anyone who has experience with C#, which is also an ECMA standard language, has been exposed to it before. For a lot of people who design promises, promises were a stepping stone towards async await, which builds higher level abstractions using promises as a building block. The problem is Node doesn't really have the best support for promises. And so we find ourselves in a really tricky situation. How do we properly support this new language feature that people are going to use without breaking all of the tools that we have already set up for debugging, for introspection, for postmortem analysis? So this in turn led us to develop a new utility called util.promisify that came in Node v8. Has anyone in the audience used this at all yet? A few people? That's cool. I appreciate it. The thing that was really cool about util.promisify, we've seen promisify in various promise implementations like Q or Bluebird. But what we could do in Node that was different was, because we embed V8, because we can operate at the C++ level with the VM, we can actually allocate memory at a low level And we were able to create less memory and less objects with our Promisify implementation that would not only outperform other promise implementations, but be closer to the metal. And with the util.promisify and async await, we've actually measured instances where async await can outperform callbacks, which is like not what Node programmers think is going to happen. But this required all sorts of weird refactorings to domains. And I'm not going to ask how many people know what domains are, because they're deprecated, and you shouldn't. They're technically deprecated, but we don't have a better solution. Domains are an API that we have in Node that allows us to create a new context, execute code in that context, and if things blow up, you're able to kind of like manage the context, do introspection into what failed. If you're creating any sort of like runtime or like something that's going to execute third-party code, domains are a really great solution to doing that. It's deprecated and we tell you not to use it, but we haven't come up with a better solution. But this then even became a further problem for postmortem analysis. And postmortem analysis is if Node crashes and you run it in a certain mode, you can get a core dump of like what was the state of the heap at the time in which Node crashed. And you can go in and do analysis of that. But for promises, you have this problem of uncaught exceptions. So if you're not running a catch on your promise, which can end up happening with certain patterns with async await, you don't throw. And if you don't throw, then you don't core dump. And if you don't core dump, you can't do postmortem analysis. And so this kind of core philosophy in Node that we had that enterprises are using in production right now is just no longer able to work. And so if you somewhere in your like thousands of modules that you have something that throws, you're kind of like, uh-oh, like what do I do? And the problem is that a lot of our assumptions that we had in Node were based on callbacks. And as much as people in Node wanted callbacks to just be the future, it's not a committee of 10 people who gets to decide how people write code. And a lot of people are using promises. And we need to be empathetic to that. We need to create tools for people who are going to do it. So the language is moving, and the people are moving with the language. And if Node does not find ways to fix this, we're going to not be the tool of choice anymore. The language evolves, and we need to keep up. Just going to stare at the Pokemon for a second. All right, that's good. But so let's take a step back and look back at how a language Babby is formed. How does a feature get made? So the spec is ECMA 262, as we were saying. And the committee who implements it is TC39. TC is short for Technical Committee. The committee meets every other month at locations around the world, as distributed as San Francisco and Palo Alto and Seattle and Portland. But jokes aside, we did a meeting in New York this year. But there's actually discussion about trying to do a meeting in Europe next year, which would be really awesome. And the participants who show up include major browser vendors, so people who are actually working and building all these different virtual machines, academics who are studying complexity of machines and complexity of languages, industry experts who happen to know, I'm the expert in promises. Like, one of the individuals who sits on the committee is one of the people who invented promises, and he helped to develop the promise patterns that we have in Node now. Open source maintainers have been invited as experts, so maintainers of Babel or people from the Node project, and maybe you? Can anyone join though? Anyone? Kind of. You can get invited, but to show up you have to be a member. And we saw that list of members before, and you pay in to become a member. Now, the number that was up there, 70,000 kroners, is to be a fully voting member. There are other memberships that are available. I believe an individual membership is either 3,000 or 5,000 US dollars. There's academic memberships for universities. And if you're coming in as an individual or an academic member, you don't get a vote. But as we're going to learn very soon, just like whose line is it anyways, the points are made up and the votes don't matter. What we have is a bunch of delegates. So every organization sends a group of delegates, sometimes too many delegates, as many people feel about like organizations that maybe come rolling in with like 20 people. But there's no actual limit or specific person who can show up. So Google's a member, and Google maybe has 5 or 6 or 7 different groups with vested interest in this, from people who are working on Node, to people who are working on Chrome, to people who work on just generic web standards and what working group related stuff, to just like the person who wrote the original implementation of ES4. So there's all these different stakeholders who end up going. At Google, we actually hold meetings before the meetings to make sure that we're going to be on board for the meetings, so we don't unmute while we're meeting. Which leads to the question of how features get developed. Consensus. And this is different from consensus seeking, which is the model that we do in Node, where it's like, hey, if I say this is good and no one complains, then we do it. But if we do complain 50%, that's how Node does it. At the TC39, you need full consensus. If any one person does not agree with a feature moving forward, it doesn't move forward. If someone thinks a feature is not going to land, it's just not going to happen. So the amount of consensus building that you need to do, the amount of research that you need to do, the work you need to do is quite vast. There's many stages to the proposal process as well. So it starts with known as a straw man, which is stage 0, which is just kind of getting the idea out there, letting people know what you're thinking about doing, seeing if people are on board with the idea, starting to like just get it out into the ethos. The first stage is a proposal. So you can come with a straw man and have it promoted to a proposal in a meeting. But to move to a proposal, you need to have a high-level API design. You most likely need to have an implemented shim so that you can test this feature out in a browser. And you need to have what's known as a champion. And at the TC39, a champion is the person who is taking responsibility of making sure that this feature is seen through the entire process. This creates a bit of a disconnect for people from the community who want to see features moving forward. So if you're involved in like the ES Discuss board, or if you're on GitHub contributing, it can be hard to actually move things through these stages unless you can get someone from the committee to be a champion for you. Thankfully, we have some individuals, specifically I'm thinking of Leo Balter, who is actually taking time to explicitly work with the community and find proposals from the community and be a champion for community proposals, which is really great. So once you're at stage 1, you have a champion, you have a high-level API, you have a basic shim implementation. To move to stage 2, which is a draft, you need to start working through the actual spec language. Because the spec is not implemented in code. It's very specific language, and we'll look at an example in a minute, that dictates how the feature is actually implemented and the underlying algorithms that make it up. So to move to stage 2, you actually need that first set of like spec draft and having some people reviewing it. So the movement really from proposal to draft is moving from a code draft to a spec draft. The third stage is a candidate. To reach the candidate stage, you need to have a finished draft, like this is ready to go into the standard. And you also need to have what's known as a test 262 test. Test 262, I'll talk about a little bit more after, is a project to build a test framework for compatibility and standardization. So you can take the test 262 test suite. They have a Node.js runner, a Python runner, and a browser runner, and you run it in your environment, and it can tell you whether or not your JavaScript engine is compliant. So to move to stage 3, you actually need to have all the tests written for your spec and the spec to be finished. The final stage, which is finished, which is like you're going to be in the standard, To get there, the spec needs to be completely finished. You need to have sign off from members of the committee and the author of the spec itself. And the most important part is you need to have 2 implementations in the wild. And then this kind of flips things a little bit, because you think, why are people going to implement things that are not in the spec? But browser vendors and VM authors are constantly coming up with features that they're putting behind flags to test out these things as they're moving forward. So for things to move into the standard, they don't even get standardized until at least 2 of the vendors are shipping it. And at that point, it can end up into the standard, and once it's in the standard, it gets implemented by everyone. So Test 262, as I was mentioning before, is a project. A lot of the work was done by a consulting group called Boku. Leo Balter, who I mentioned before, was heavily involved in the project. And I really suggest if you're interested in getting involved in this stuff, Test 262 is actually one of the places that has a lower bar for entry. The people who are maintaining the project really want to get external contributors. The way to contribute is extremely clear because you can just send pull requests over to the tests in there. You can go through and look at the tests for all the different features in the browser and learn about how it works. One thing to make sure of, to just let you know though, is that you can't warp through these steps. Each step and each stage, you can only move up 1 per meeting. And with a meeting every other month, it means that the shortest period of time that it can take to get from an idea of a feature to something being shipped in the standard is about 8 months, which is a commitment. And through those 8 months, you're going to 4 week-long meetings. And then you're also writing a spec, you're writing the draft, you're writing a shim, you are getting 2 implementations in different vendors. This is a real undertaking. And a lot of the people who are seeing this through, this is their full-time job. And this is where the balance becomes hard, because as individuals in the community, you want to contribute and you want to get involved, but there's a really high bar for the work. And that's why I think the Test 262 project is really interesting, because you can find these little piecemeal works. You can find a champion who has a stage 2 proposal, and you can work with them on putting together the Test 262 tests to help them get it to stage 3. This is a great way to learn, be involved, help things ship in the language without having to make, like a 1-year commitment of your life. Every year, a new version of the specification is published. This is the only time that I've ever seen a vote happen at the committee, which is basically everyone sits in the circle, like all the tables are there, and they're like, okay, do we all agree on this spec? And like nothing is gotten in there that doesn't have consensus. So literally one of the delegates from each of the member companies just says yes. So that's the only time it votes. And the thing that actually becomes interesting about this is, because this is like such just kind of like we do it because we have to from like a standardization and like a legal perspective, the spec, the yearly spec, is not viewed as like the source of truth by many of the people on the committee anymore. In fact, the GitHub repo is viewed as a living specification. So again, if you're interested in getting involved, you can go through and look at the TC39's GitHub repo and look at the ECMA 262 repo in there and start reading the spec. Find some spelling errors, send it in the same way that you would get involved with any other project. You can author changes on the like on the ECMA 262, you can author changes in the JavaScript language without having to, drive a feature. In fact, there are many people who think we have enough features as it is. So this is an example of the null type. This is the whole spec doc for it. It returns null. This is a slightly more wordy one, which is array, and we can walk through it. It's like, if type arguments is not an object, return false. If it's an array, an exotic object, and I don't know what that means, but I kind of want to find out why it's so exotic, return true. If it's a proxy exotic object, which is extra exotic, then it gets really complicated. The thing that I think is really interesting about this is proxies have not always been in the language. So what you can see here is array, which is something that has always been in the language, actually had to be fleshed out for new features to come in. And that's actually part of stage 1 and stage 2 of the process, is you actually need to work out mentally all the ways that your feature will affect all of the other features in the standard. And this is part of the reason why you end up having to work really closely with all the different people and why it's so hard to reach consensus, because the consensus may not even be like, hey, that's a bad idea. The consensus could just be like, hey, if you do this, you're going to break this, this, and this, so we need to spend like 3 years to figure out how not to break things. JavaScript engines implement the specification, but, and this was from earlier today, I was making jokes on Twitter, and Brendan said, think of the spec as another implementation with only mental execution, but in minds of leading engine implementers, feedback among all implementations. So he's kind of saying then ECMAScript is JavaScript's monster? I don't know. Because if the spec is just another implementation, it's not this hierarchical thing, which is how the mental model that we would want to have is like the spec and then the implementations. The spec is just another implementation that everyone works on together. So let's recap this really quickly. We have the TC39, which is the committee that makes it. We have ECMA 262, which is what they make. We have V8, which is an implementation of Test 262, which has been made by TC39, which has some people from V8 on the committee. And then we have this Rocket Turtle node thing, which just ships it so we can write JavaScript, so we can make Twitter bots that post stuff. So V8 has a C++ API that's used by Node and native module authors. The compiled code relies on what's known as an application binary interface. So when you compile C++, you get this binary, and you can think of it as a whole bunch of bits. And each function call is just pointing to somewhere in those bits. And so semver minor changes to the V8 API can actually move around those bits and end up being semver major changes to the ABI. So what this means is that if you compiled things with one version of Node and then try to run it on another version of Node, it explodes. This is how things get weird for us too, like as if like language features wasn't enough. We have to worry about a binary interface. So this is independent of actually checking changes in the API itself, which if you're also writing directly against the API and V8 changes their API, it breaks everything. So the Node project came up with something called NAN at first, which you may have heard of, Node, Native Abstractions for Node, which was an API abstraction so that the V8 API changes wouldn't break you. But it didn't actually do anything regarding the ABI problem, because the ABI underneath it would still change in between versions. So in came the NAPI. I'm not actually allowed to call it that, it's the NAPI, but it sounds so good. And the NAPI is a new ABI stable abstraction that's in Node. And what it means is that V8 can make updates to their ABI and have a loose shim, and it doesn't affect the code. So if the ABI is stable, other engines can shim against it. So now you can use any engine in Node. You can compile once, use it across any version of Node. You could then go and replace, let's say, V8 with Chakra and still run it again. Compile once and run anywhere. This is kind of the future that we're hoping for. Its shipping is experimental in Node 8, so take a look. But you know, there's a lot of moving parts here. And we're trying to build abstractions around them so you don't need to understand anything. Because I can tell you, I personally, like, I know just enough to get up on here and not like start crying due to complexity. But we do this work so you can focus on products rather than getting lost in the tools. And I think like after all of this, the most important message that I can give is like just forget everything I said and focus on making great things. Focus on JavaScript. Thank you. This is a surfing dog.